crank that up anymore? Let me see here. Maybe I can crank that up just a bit more. Nope, that's the maximum extent. Okay. Boop, 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 boop. Oh, all right. All right. So, good afternoon, class. How are we doing this afternoon? Not too bad. Exam season is barreling towards us like a juggernaut. So yeah, I've been working on, getting exams ready, basically, which is, not the most fun job in the world, but so it goes. So, I'd like to introduce assignment 5. Assignment 5 is on the topic of polymorphism, inheritance, static stuff. This is like peak object-oriented for this class. This topic is actually peak object-oriented. After this, we're going to talk about exceptions and mouse events, which kind of leads us off the course kind of a little bit gradually into a bit of a softer topic to land on. Technically, there's also lists, which is like topic 12, but this is kind of like a optional topic if we have time for it. So, this assignment is about polymorphism. Is the camera running? Maybe it is, maybe it isn't. Let's take a look. It is. Okay, good. This assignment is about polymorphism, abstract classes, and interfaces. The UML class diagram below shows an arrangement of classes with inheritance, association, and implementation relationships. Your job is to implement the classes and relationships shown here. So you are implementers of this UML diagram rather than designers of a system for this one. So we have 1, 2, 3, 4, 5, 6 different classes to implement. Plus, I believe in the description you're supposed to add a couple more of your own design. So, the classes in the diagram represent products that are available at Tim's. Tim's Donut Shop, as it were. Definitely not copyright trademark. Some of them are consumable, and some of them are not. Each one is a Tim's product and a commodity. So if we take a look here, we have two interfaces, commodity and consumable. Some are consumable, donuts are consumable. Some are not, mugs are not consumable. So, you must add one more consumable product and one more that is not consumable. So you must add 2 additional classes to this diagram, kind of based on ones that are there already. One is a consumable item, the other is not a consumable item. Also represented is Tim's order. This class has an array containing one or more Tim's products, representing a named customer's order. The plus on the association arrow means one or more. Right there, one or more. Very good. So a Tim's order has one or more Tim's product, which are any of these things with these interfaces. So far, so good? Good. So, alright. Implementation notes. The get consumption method, in consumable, should return a string like drink it or eat it as appropriate. This tells you how the product is consumed. So, as you can see, the interface has 2 abstract methods. get calorie count, and get consumption method. If we recall from way back before the test when we were talking about abstract methods, an abstract method is a way of constraining a class and telling it, you must implement this method, right? So, when the interface consumable has these two abstract methods, anything which implements it must implement those two methods. Otherwise, it's not an implementation. Does that make sense? So far, so good? Okay? If you have any questions, stop me at any point. Constructors versus create methods. So this is a little bit different from what we're used to. Note that many of the constructors are private. Constructors are private. Uh-oh. Interesting. The classes with private constructors have static create methods. Instead of calling a constructor, call the create method like this. Mug_m is equal to mug.create. So basically we're kind of making our own constructor to an extent. This method will have a dialogue with the user to collect information about the object. In this case, color, cost, and price. This will then create and return an object by calling the private constructor. When you add your new products, you should also follow this same pattern. The Tim's order class also uses a create method. This method asks the user their name and how many products they want. Then it creates a Tim's order object by calling its own private constructor. Then for each item in the array, it asks what type the customer wants, etc., and calls the appropriate create method and stores the results in the array. So, this is a bit of a strange way of doing this. It may seem. So far, we have not really done anything in this manner. What's the advantage, do you think, of using one of these create methods as opposed to just using the constructor?
Would it be that it's easier to fit into the model view controller framework?
Well, in a way it kind of breaks it, actually. Under this scheme, Mug and Donut both have create methods. The purpose of the create method is to interact with the user. You would think that we would externalize that in a view class, but in this case it's distributed in among all of the rest of the classes. So no, this particular example does not follow our general model view distinction. We're kind of taking the view and breaking it up according to each of the individual methods, or each of the individual classes that the view is attempting to create. Yes, sir?
Is it to avoid privacy leaks?
To avoid privacy leaks, yes, could be. So the purpose of the constructor is to say you must create this thing in this particular manner, right? What the create dialog, the advantage of that over calling the constructor is that you don't need to know these values when you call it, right? Those values are obtained from the user by the method. So, you can create a mug without needing to know name, color, cost, or price, right? So, the alternative to this, which is the thing we've been doing so far, is you write a main method which has a bunch of user interaction, right? You acquire these details, and then you call the constructor. In this case, we are taking that interaction, right, and we are sneaking it into the class itself. so that we are containing more of what the class needs to exist in the class itself. So that's the advantage here, right? We are relying less on an external interaction. We are relying less on public static void main, and we are pulling pieces of public static void main into and distributing it across our class hierarchy. This is better from an architectural standpoint because you're grouping the code with the thing that it applies to. This is generally what we want with object-oriented programming, right? I'm sure all of us so far have had kind of that problem where it's like, where was that in this great big interaction with the user that I have that's like literally 200 lines of code, like where is the bit that does the car class or whatever it was, right? No more. In this, you always know where that is because it's in the class itself. So that's the architectural advantage to doing it this way. It's a bit more of a Java idiosyncratic way of doing it. It's a bit more Java-y. Oh, and sorry, you have a question?
No, I'll wait till you're done, because I have a question about this assignment, but when you're done, your point.
Sure.
Okay, so the Tim's product, the italicized style means that it's abstract, right?
Yes.
But none of the methods are italicized, nor the instance variables. So does that mean that's confusing to me, because I thought an abstract class needs to have at least one abstract method.
In Tim's product, you mean?
Yeah. Because in the interfaces,
Otherwise, what's the point, right?
Yeah, like in the interfaces, they're all italicized methods, so those are abstract methods too. But like in Tim's product, none of those are italicized. So does that just make it a regular class then? Or do we choose? I don't know. That was the only confusing part to me about this.
There are methods in there that we could make into abstract methods.
Okay, so it's up
Right?
to us, like our subjective.
Well, yeah. The only thing I'm thinking of actually is toString, right? But everything has an implementation of toString anyways. I think in this case, if we added to this description, we might find something that we want to make abstract that is neither here nor there, right? But given its existing implementation as it's currently laid out, just make it abstract, but give it no abstract methods.
Okay.
Follow the well, it does do one thing for you, right? It prevents you from creating an object of this type, right? Like there's no such thing as a Tim's product that isn't a mug, a donut, or any of the other two things that you want to put in there. Much as companies would love to sell us the abstract idea of a product rather than an actual product, we are not yet to that level of societal sophistication, so they still have to sell us an actual physical product. So that would be one reason to have that as abstract, is it constrains you from creating objects of that type. Make sense?
Yeah.
Cool. Any other questions? Very good. Yes, I think I've banged on around, so there's even a comment here on model versus view. So in a sense, we are still separating model and view, but the way that we're doing it is by class rather than by the entire program, right? There is one other thing that I wanted to say. So, and this is another this is a Java culture thing that you should know if you have taken a course on Java, but I don't think it appears anywhere. So, normally when we have public static void main, it's in a main class, right? Or you call the class view or something like that, right? But any class can have a main method, right? Any class in the hierarchy can have a main method. According to the way that Java programmers program Java, the purpose of main methods, which are not the top level main method, the purpose of those methods is to give you a testing suite for the class that the method is contained in. So, for example, if you dropped a main method in donut, the purpose of that main method would be to test the donut class. So what you would do is you would create a static instance of itself within itself, and then you would run various methods on it with various parameters, and that's what a main method should be in any class that's not the top level class that you're running for the program. Does that make sense? Okay, good. So, test class.java, use the code below to test your classes. That's like you're given your top level code here. I'm hoping that most people could have, kind of found their way to that one without it, but, so it goes. General advice, go top down. Start with the highest interfaces and classes and work your way down. Particularly, like, if you're implementing something that implements an interface, you kind of need the interface defined before you start implementing it, right? So that at least you have to do, right? But yeah, in general, that's good advice. Start with your subclasses and work your way towards the superclasses. Make instance variables and easy methods. For more complicated, Make instance variables and easy methods. For more complicated methods, just create stubs for now. Oh, I see what it's saying. So basically fill in the easy stuff and leave the harder stuff until you've fleshed out the structure. That's the advice it's giving. A method stub is an empty method. You may make this first and fill in the details later. It's a little bit like making an abstract, but kind of just like leave a comment in there that says to be done, or nothing for now, something like that. This is a method stub, right? Once you have the entire structure created like this, you can start filling in the details of each method. So, does that make sense? Any questions? Okay, good. Assignment 5 then. Let's talk due dates. I think it's going to have to be the 1st. I can't make it tomorrow. Plus you've got assignment 4 from JavaScript, right? But that means that assignment 6 is going to have to be due on the 8th, which is kind of just,
It is what it is.
It is what it is. These Java assignments are designed to be 1-week assignments anyways, rather than 2-week assignments. Okie dokie. Okie dokie. So we'll just pencil that in then. Ba, 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 ba. There we go. Good. So, back before the test, we got a certain ways into this unit. I think we got actually like through most of the important conceptual work here. But let's review, starting at abstract classes and methods, and we will we'll do our usual thing of doing some Java examples along the way. Sound good? So, so abstract. Anybody care to tell me what abstract means? It's kind of a difficult term to define, actually. It's such an abstract term, right? It's difficult to define. So, the quality of dealing with ideas rather than events, freedom from representational qualities in art, a state of preoccupation. There we go. That's probably that's probably closest. The process of considering something independently of its associations and attributes or concrete accompaniments. So, in the case of object-oriented programming, an abstract method is a method that has no body, right? It doesn't contain any statements. It cannot perform any work. The purpose of an abstract method is to define an interface. We know what's going in, we know what's coming out, we are not concerned about the interior. That is the purpose of an abstract method. The way that they are written, you write the first line of the method, and then rather than open curly braces, you put a semicolon. So, let's open up IntelliJ. No. 24, there we go. Let's make a new class. What should our example be today? Should we do something video gamesy? Yeah? That's still a pretty broad topic. What should we do specifically? Fantasy RPG? Sure. Okay. Let's do goblins. Goblins, yes. Goblins, good. So, goblin. You want to know something fun? I've convinced my children, who are very young, that there's such a thing as a grublin. Grublins are things that come along and eat the food that you drop off of the table on the floor. So if you can't drop food off the table or else the grublins are going to get it. So, let's see here. Goblins. What do goblins have? Well, here's a question. We have goblins. Alright, sure. What are goblins? Let's go up one level. Let's make something that, let's make an interface. What do goblins do? What attributes do they have? What's a set of things that a goblin can do?
Creature actions.
Creature actions, sure. Okay. So, let's do a new class. Call it creature. There we go. Public. let's start this off as an abstract class. Alright? Well, the reason that you make it an abstract class is so that you can put abstract methods in it, and also so that you can't actually instantiate a creature. If you were to play good old Dungeons and Dragons, would you ever encounter a creature? No, right? Like, no matter what you encounter, it may be a creature, but it's always something else as well, right? So creatures would have, let's say, public abstract void move, right? Int x, int y. I'm kind of imagining like a, like a 2D grid kind of thing. In order to move, they would need a position. Private int x position, y position, right?
What about name?
A name is a good one too, yeah. Private string name, good. That's probably enough for now. Let's insert a constructor that does all those things. There we go. So, public abstract void move. Move should take new coordinates and, well, we should actually document that, shouldn't we? Takes x and y and translates by that amount. There you go. So, good. Public abstract move. So now, goblins, which extend creatures, as soon as we say that, it tells us, goblins must either be declared abstract or implement the abstract method move. Right? Now, this is like perhaps a slightly better example than you might think. Because you may think to yourself, well, why wouldn't we just implement move inside of the creature class, right? All creatures move. Why wouldn't we have a definition at that point, right? Well, as any good fantasy RPG player will tell you, not all creatures move in the same way. Not all of them have the same rules that apply. For example, ghosts. What do ghosts do when they move? Well, they float, yep, so they're immune to sort of like terrain-based traps. They can also pass through walls. So they actually ignore terrain entirely. Right? So what you could do, right, you could make that like a Boolean at the level of creature, have a little tag that says ignore terrain, right? But the number of creatures that ignore terrain is actually probably going to be pretty small, right? So, it makes sense to pop that down the hierarchy. You can also have a ghost that ignores terrain, right? But let's just keep it to goblins for now. So, we should probably have a constructor for our poor goblins. There we go. Let's see. Perhaps we should have what are they called? Instance variable. Private, let's see, what do goblins have? Pointy ears, green skin, greed. Goblins are pretty greedy. Private, int, greed. There we go. There we go. So when we initialize a goblin, he has a name, a greed score, and a position. So far, so good. But we still need to implement move, right? So, public void move. So the way that you implement a method is by overriding an abstract class, right? It's not really overriding in the true sense. There's no like base class definition that you are replacing, but effectively it's overriding the abstract, overriding is the mechanism even though it's not quite the same thing as overriding, right? Int x, int y, there we go. If x plus y is less than 6, then I suppose we could have it return Boolean for success or failure. That's okay. We don't actually have x position and y position exposed, do we? I'm just going to cheat. There we go. I cheated. I hard-coded the speed. Bad professor. Bad professor. I hard-coded the speed. But, that will do. That will do for an implementation. Right? So now, everything's happy. You'll notice that our error has gone away. We are implementing the abstract method. Everybody's happy. Right? So, just to prove it, let's write a quick main class, the purpose of which mostly is so that I can choose a humorous goblin name. Goblin G is equal to, because that's how they appear in Dwarf Fortress, new goblin, could be X position, let's say 15, Y position 2, name. What's a good goblin name? Gremph Nubble B. There you go. I don't know, not too many, not enough hard consonants. Granked Nubblebee, there we go. And lastly, a greed score, let's give him a 7. There we go. G.move 3, 6, 3, 1, so that it's valid. There we go. Run. Doesn't actually output anything, but everything compiled and ran, so we're good. Cool. Does this make sense? Abstract methods? Good. So, another good example, we've had this running example of geometric objects for a few weeks now. A geometric object itself is in the same category as a creature. It's a thing that exists only insofar as other things are it, right? A circle is a geometric object, but there's no such thing as just a geometric object that's not something else more specific, right? It's a category, right? It's a category, but not a specific thing. It's kind of like human is a category, but it's not like, there is no, you could not go out and, take a big rubber mallet and hit human on the head. Not possible, right? You could hit a human on the head with a big rubber mallet, but you cannot hit the abstract concept of human in the head with a rubber mallet, right? So, good. So, now let's talk about interfaces. Interfaces. So what abstract methods are doing really is they are a way of obligating subclasses, child classes, derived classes, to implement certain methods. You're saying, okay, everything that inherits from me has to do this, that, and the other, even though I myself am not really capable of providing that definition. Okay. So, what happens if that's all your method has, or all your class has, right? All it has are a bunch of abstract methods, right? Well, first of all, because all it has are abstract methods, and you don't have any data in there whatsoever, not even static data, there's a constraint that's lifted, right? The constraint that's lifted is that a class can only extend one other class in Java, right? Java does not support multiple inheritance, right? Some other languages support multiple inheritance. Python supports multiple inheritance, but Python is a garbage language that does garbage things like multiple inheritance. Oh man, what time is it? Do you want a very brief digression on why Python is garbage? Like its classes? Alright, buckle up. Watch this, guys. I'm about to do a nerd. Alright, so you guys have been doing Java so far, right? Would you say that the concept of things being private and public is important in object-oriented programming?
Yes.
Good, that's the right answer. What's the point of a private member? Come on, what's the point of a private member?
Encapsulation.
Encapsulation, which means that things outside cannot see it, cannot write to it, cannot read from it, right? That's the whole point of something being private, right? Come on, load. Load, darn you. Come on. Whenever I need a quick little Python environment, I use this thing. Although, we'll have to see if it actually works. Do they have idle? Is that like native on the thing? Oh, you don't say. Come on. Okay. Something that really irritates me about this, it's a graphic of a spinning circle rather than like something nice, but it's like slightly off center, so it's like wobbling as it's garbage. Alright. Do I have anything idle? No?
No, idles also.
It's on the mouse.
We used it in the first semester.
You have to type in Python.
We are struggling to connect to the server. I hate doing this.
Maybe it's just the whole internet.
Is it the whole internet?
Seems like
Okay, I can't really blame Mohawk apps then if that's the case.
that.
Yes, you can.
But you can't normally.
Or I can say that it's so terrible, it broke the internet. Good grief. Okay, do you mind if I try turning it off and on again?
That's step one.
Yeah? Alright, save this file. Save. Oh man. Goodness me.
Why do things be easy?
Well, it's interesting, right? Yes, I don't care. You're restarting. You're exactly the problem I'm restarting over. It's kind of fun how, like, recently Windows made it so that, like, shutting down, not recently, but within the last 10 years, they made it so that shutting down and restarting isn't actually shutting down or restarting. It's like putting it into a deep hibernation state. So it's like, you don't understand. That's the way we fix you, is by actually shutting down your stupid garbage operating system.
For some reason, whenever I shut down my computer at home, it just restarts.
Yeah, same.
Oh, really?
Mine doesn't even shut down to go to like I click it, it goes through the process, and then boots me back up to like the password screen.
Yeah,
So
Yeah.
I turn it off and then turn off the power bar. It's like, now you're off.
yes.
Mine's only when it pops up to that screen where it says to like force shutdown because you have something running or something like that. If that screen ever shows up, then it restarts every time.
Yeah, like, off means off. No means no. No means no, Windows. Good grief. This is also taking way too long.
Yeah.
I'm kind of like not sure that I would have even been able to teach, actually. I think this, I just happened to be on a digression, but like, alright. I bet it's still that stupid devirtualization thing that's hanging it too. Boop. So there's a quick little fix for you, everybody. If you hold the power button down for like 5 seconds, you get an actual hardware reboot.
What's that between 10 years?
I just about had it with Windows when like the little messages that they give you started being like mildly abusive, you know? Because it used to be that Windows was polite, right? It used to say, please don't turn off your computer, I'm updating. Now it's like, don't turn off your computer, idiot. Just don't do it, moron. It's like, okay, Windows. It's like at a certain point, it's like, you know that thing in like science fiction where like the computers take over and like at some point you transition from the computers serving you to you serving the computers, you know? Well, I don't know if we're to that point yet. I don't know if we're over that threshold, but the way that Windows talks to you these days certainly makes you feel like you're over that threshold. All right. Okay. Do you internet? Can we internet, please? Looks like we can internet. That's a page. That page loaded. Let's see if we can break it again. There we go. There you go.
That's good. What is the hover over text?
How could you choose avoiding a little pain over understanding a magic lightning machine? All right. We have, okay, so it does seem like things just, okay, I don't think that was actually Mohawk apps. I don't think that was their throat. Okay, all right. All I wanted was a Python interpreter in my Java class. Is that too much to ask? Apparently it is. All right. Behold, the Python interpreter. Did you guys actually use the interpreter during your Python class?
Idle kind of does have a view that does show the interpreter.
Okay, but like, did you use it?
Kinda, yeah.
Kinda. Yeah. Okay. If you didn't know, you can just enter Python code into this thing and it executes. So, objects. All right. So let's declare a class. All right. This is how you do a constructor in Python. Allow me to destroy your happiness. It has to be called init with 2 underscores before and afterwards. The first argument to every method in a Python class is the name of the, it's like you're setting the name of the self-referential reference. So like, you get to set this, you know this in Java? It's this, but you get to choose the name. And that's worth cluttering up the, and you have to use it every time. Every time you have to use it. So, self.x is equal to 10. Alright? Would you like to know how to make a variable private in Python?
Sure.
Anybody already know? Self.__y is equal to 20. Yes, that's right, folks. You prepend the variable name with 2 underscores, and that makes it private in Python. Guess what? You have to include that every time. It's part of the name of the variable. Every time! You have to include it every time! Ugh. All right. Not only that, guess what? Guess what you can do in Python? That's right. You can have a public and a private version of a variable with the same name. And that's legal. So A is equal to A. There you go. A is now an object. A dot x is 10. A dot y It says, I don't know if I have a Y. Well, it's actually true, because, like, there you go. What? I don't have a private Y. What are you talking about? Alright, Python object. Tell me your secrets. So every object in Python has a dictionary attribute, underscore, underscore, dict, underscore, underscore. It is a dictionary of all of your variables, even the private ones. So, you notice anything about the names of the private variables there?
But you can't see it, it's private.
Well, is it true? Is it true that you can't see it? Literally all you need to do to break into anything that's private in Python is you take one underscore, the name of the class, which you can read easily, and then underscore, underscore, the name of the variable that you want. You can even look them up. You can loop over this. You can loop over this. It needs stupid Python. There you go. So you might be saying, okay, well, you can see them, but you can't write to them, right? That would be ridiculous if you could write to them as well. Did that just work? And because types aren't types in Python, you can just write it over an integer. So, when I say that Python doesn't do classes very well, and that Java is better, that's what I'm talking about. Yes. Okay, so, yes.
So which one do you hate more, Python or JavaScript?
Well, in Python at least you can't do this. Watch this. This is fun. Empty string is equal to 0. Empty string, or yes, 0 is also equal to a string containing 0, right? And you would assume by the transitive law of equality that that should be true, but it's not. So basic laws of logic don't hold in JavaScript. So no, JavaScript's also an awful language. They both have like their own reasons for being awful, you know? But like, okay, every time I've brought this up to a Python enthusiast, try to guess what their defense is. Guess how they try to defend their crummy language, and I'm talking to you, Internet. No, the camera. No.
Did they just say like it's used for different things or something, or?
No, their defense is even worse than that. Their defense is usually, well, why do you need private anyway? It's like, if that's your defense, why would you even put it in the language in the first place? Alright, anyway. Yes,
So if private variables in Python are accessible, what's the point of the Python or the private variables in Python? Do they do anything else? Or are they like a false sense of security?
they're a false sense of security. So, like, if you want to dig into this argument a little further, right, there's probably a way of making Java objects expose their private members as well, right? But there are more guardrails up. Like, once again, we come back to this constant feature of, the principle of security, right? There's no such thing as absolute security, right? All security is merely a series of increasingly strong deterrents, right? So, some level of, no, you can't do it, that it's private is like, yeah, okay, alright, fine. I can still break it, but it's like, it depends on like how much language knowledge you need to like break it. In the case of Python, like you literally just need to know the name of the place it's stored and you can look it up, right? Java, it's a bit more like it would be a little bit more abstruse, I imagine, right? I don't know how to perform the same operation in Java. Leave a comment in the comments. But yeah, it's like, yeah, it's, my view is that it's a false sense of security. If you think you're making it private in Python and that means they can't touch it, that's not true. It's more like, please don't touch this, guys. Right? Alright. So, where were we? Before the internet failed because of how terrible Python is. Yes?
I'm just curious, are there any like large programs that you know that are programmed in Python that are relatively common or popular? Like,
oh man.
it's like I can't think of any that are.
A lot of the time, like sometimes you see Python scripts get that big, but like most serious people consider Python a scripting language, right? To do small things with because it lacks suitable abstraction mechanisms to handle largeness, right? Like the thing about Java is that Java scales really well. That's the point of all of this stuff that we're doing, is that Java scales really well because it's a more formal language with good abstraction mechanisms. Python was always kind of intended as like a replacement for bash scripting, right? In a sense, it's bash scripting for people who don't have a bash prompt. Oh, that's my... That being said, there are a lot of like you hear a lot about like machine learning and artificial intelligence stuff that goes on in Python a lot. Guess what, folks? The Python's really a wrapper for C++ libraries. The same is true in image processing. Almost every like high-octane Python application, Python is wrapping a C++ library because people don't want to program in C++. But I mean, I'm sure there's something out there, right? Nothing comes to mind though. Like you can write, well, of course, Dropbox. Oh, that explains this. That explains a lot about it. I don't think that that's. Thank you, Cora. I don't think that that's like what we're talking about here. Good grief. Oh, I can think of one. Civilization 4 was written in Python. There you go. There's one.
I would have never guessed.
Yeah, it's like, I only know that because I used to play that game a lot. And like during the loading screen, it's short, but you can catch it. It says loading Python scripts. It's probably not completely Python, but at least it uses a fair amount of it. Enough to have to load it. All right, programming in Java. Java. All right. Let's see here. Scroll. All right. So, a couple of things. Number one, a class may implement as many interfaces as it likes. All you're doing by implementing an interface is you're saying, yes, I agree to these conditions, right? That being said, you can still use interfaces for the purpose of subtype polymorphism, right? So if you want to say the argument to this method must be edible, you can say edible X, and then whatever you put in there has to be a subtype of edible, which means, chicken or fruit, but not tiger in this case, right? So you can use subtype polymorphism to, I guess technically a tiger would be edible if you were able to catch one and kill it, and you could theoretically eat it. But generally, we try to avoid eating other top predators out of respect. Being top predators ourselves. It's like, you've earned us not eating you. Also, bioaccumulated toxins. You should try to avoid carnivores in your diet. But anyway, so you can implement a few of these things, right? In this example, well, we only have one interface, so it's a bad example. I'll show you another example in the rest. So if we had a bird interface, chicken could extend animal and implement edible bird. And edible bird is actually not a bad description of a chicken,
Okay, so that implemented two abstract classes.
Yes,
Or sorry,
But,
two
sorry.
interfaces.
two interfaces, yes. We'll do an example of this. So, this is an optional extra. So we're going to skip it. I don't want to have to tell you what one of those is just yet, although I think I already did. Let's get into the programming exercises. Exercise. We did this one, right? Good. Let's take a look at this. This is an extension of our interfaces example. All right. Change the example code for the edible example available on eLearn. Ooh. That's how many years has it been since this has been updated? eLearn was the thing that we used before we had Canvas. But of course, this is Java we're talking about, which hasn't substantially changed since the 90s. So basically, this is an extension of our previous class hierarchy. We have now 3 interfaces. Edible, animal is now an interface, and catchable. We have fruit, an abstract class inheriting from edible. We have oranges and apples, which inherit from fruit. We have chickens, which are edible, catchable animals, right? We have tigers, which are animals, neither catchable nor edible in this example. And we have bats. Bats are catchable and animals, but not edible, in theory. So, so let's pull up the example code. Here we go. Pull out the example code zip file, please. Bing-a-bang-a-boom. Am I going to be able to reopen my my project from earlier? Yes, I am. Hooray! So, animal, apple, chicken. Well, let's see what the exercise is. How about we just make it from scratch? Yeah?
Which week are we on? Because we can, I can only see up to week, to test 2 week 10.
We are on week 9.
We are on week now.
Yes.
Oh, no problem. Thank you.
Week 9. So,
Yeah, so the zip stuff has it all done, right?
yeah, so why don't we just make it ourselves? That's a better exercise. At least I think it should probably have. Let's see, what do you actually contain? Okay. Alright, so example code from a textbook by God. So let's make a few new classes. Let's start with the interfaces. Let's bring up the UML diagram. There we go. So let's start off by defining the interface. Edible. New. Java class. In the drop-down, you can choose interface. That's the thing you can choose. If you choose it, edible. It just says public interface edible. If you replace the word class with the word interface, IntelliJ is intelligent enough to figure out what you meant. It's an interface because you declared it as an interface. So you'll get the little green eye on the side there, indicating it as an interface. So, public interface edible. We have an abstract method, public string how to eat. There you go. Note what happens if you try to give it some content. curly braces, interface abstract methods cannot have a body. Get that out of here. Check out what happens when I try to give it an instance variable. It doesn't like that. Variable tastiness might not have been initialized. So unlike the impressions that we've been given so far, you can actually define variables in these things. Okay. I guess we'll leave that there for now. See how things go. Let's make another interface. We will call it animal. Animal, according to the UML diagram, has a sound, which is interesting because it's defined as written text. Public string sound. Again, you gotta use the semicolon. And how about you folks implement the catchable interface for me? Shouldn't take more than a minute or two. Oh, you mean like for the assignment? It's a static method, and it contains a like one of those, scanner, print statements, read information type dialogues. The purpose of it is to call the methods or call that class's constructor, and then to return a reference.
Which one? Oh, okay, yeah, I understand now. Yeah, I deleted Office Manager. It was just
Yeah, it must be redundant. Because that is an abstract method. Yes?
The notes make some keywords, because it's an interface, it won't have to
I should think so. There's a way we can test that, though. One of your colleagues has just observed, actually, the same thing I did here. I didn't use the abstract keyword, right?
For the method?
Yeah, but it's still, if I give it curly braces, interface abstract methods cannot have a body. So it's still being treated as if it's an abstract method, despite the fact it hasn't been declared as one. The only methods an interface is allowed to have are abstract. So, calling it abstract is redundant. right? It can't not be. So, yes.
If you add default, a public and string, you can add contents to it.
Oh, there you go. Extension method should have a body. There you go. Cool. So, let's make that third interface. New interface. It was catchable, right? Catchable, public, string, how to catch. So now, let's create, let's do bat together. New class, bat. Class bat implements animal, comma, catchable. There we go. You can see that it's complaining that we're not implementing our abstract methods. So let's do that. Public string sound. Return key, key, key. There you go. Public string how to catch. Return. How do you catch a bat?
Big bad.
In a big net? I'm looking for a joke answer, actually. Carefully. Actually, that one's probably, if that were, if tigers were implementing the catchable class, I would have used that for tigers, but so it goes. So, good. So I'd like you folks to implement then tiger and chicken along the same lines. And if you're feeling very ambitious, you can do fruit, orange, and apple as well. We'll take a few minutes for it. Well, if you hover over the red line, you get the error. That must either declare abstract or implement abstract method out catch. So you just need to implement the other abstract method out catch, and that will fix the error.
I know, but this one's from tomorrow. I don't know that. I haven't checked yet. I'm not expecting the next one to be too big, so I don't know, it should be long. When I was teaching at the university, I was typically teaching in like lecture theaters, and like occasionally you'd have like a big area where nobody was sitting. Yeah.
And so I would say, oh, it looks like nobody wanted to sit next to the ghost then. Didn't you hear this place is haunted? Oh, it's definitely haunted. Do you have a preference for like teaching at a big lecture or small rooms? They both have advantages and disadvantages. Advantages of a lecture theater are, well, one, I don't have to repeat myself multiple times per week, right? Like if I'm teaching 3 sections of Java, I have to give the same lesson 3 times, right? Which gets a little dull. Not that it's, not that it's bad necessarily, it's a little bit different. I like to feel I improve it every time, That's why I usually record the last one I do a week. So there's that. I don't know, lecture theaters, like you get a little bit of a little stage, and it's easier to project, everybody, like, the other thing is visibility is better in one, like, you folks at the back wouldn't have to, like, look around your computers and everybody else in the room to see the screen, because you got that nice sloped floor going on. Disadvantages, more people sleep in a lecture theater. It's always been a secret ambition of mine to have a marshmallow gun, just nail the people who were sleeping in class. I'd probably get fired though. I don't know if you'd get fired for that. Reprimanded, sure, but is that really fireable, But you're giving out candy, to people who didn't suspect it. Okay, did we get that done, or are we still working on it?
Oh, I got you.
Yeah.
Okay, so with abstract classes, you implement interfaces, and you implement abstract classes, or do you extend abstract classes?
You extend abstract classes.
Okay, yeah, okay.
So,
No, I think I kind of get it. Yeah.
you get the idea? Yeah. Okay. Yeah, it's like
Yeah. So yeah, I think yeah.
okay. Proof by contradiction. Proof by contradiction. All right. Let's say that it was possible to extend more than one abstract class, right? So let's say we have class A, which is extending, like, in a proper inheritance relationship, class B and class C, so that A is a subtype of both C and B, right? Let's say that this is possible. What if you have conflicting definitions in those two classes?
Like conflicting definition for the constructors and methods, you mean?
Or let's say we just had food defined in both.
Both being abstract?
Abstract, actually at this point it doesn't matter, abstract or non-abstract, right? But like this
Yeah,
conflict,
I see what you mean.
this conflict doesn't arise with abstract methods, right? If this were like interface B, that's my cursive B, foo, and we have interface cursive C, right? And let's say that we have some A which implements both of these, and there's a theoretically conflicting definition of foo, right? It's not actually a conflicting definition of foo because there's no body to conflict, right? It's like, oh, I'm supposed to pick up foo from here, I'm supposed to pick up the exact same foo from here, I already have it, so I'm satisfying both with this one thing, right? So in interfaces, that type of conflict doesn't arise. But, if these things have content, right, the question is, what does super.foo refer to? Does it refer to this one or does it refer to that one? It's ambiguous, yes.
Should it be both?
Well, it can't be both. You can't run two methods at once.
Like if, say, foo had a different return value and both B and C would return both of those return values?
Yeah, like, could that compile?
Not in Java.
But not run?
Yeah. Yeah, well, Java would prevent you from doing this,
Okay.
right? In stupid languages, like Python, what you do is you take super and you say, well, that would have to be like super, super A or something. I forget what the syntax is, but you have to pick which definition it's coming from, right? But it just gets complicated and messy, right? Now you're introducing the you're making your code, the very code itself, dependent on what classes you're inheriting from. You're having to use the class names of things you're inheriting from in your code itself, which, if you'll notice, in Java you don't do that, right? You just say super and it always directs one level above, and that's fine because there's always only one thing that can point to. It makes everything, neat, compact, nicely designed. Another way of saying this is that from an algorithm's perspective, if you're talking about classes and not interfaces, the inheritance tree is always strictly a tree, right? So tree structures look like this. You should get to know trees. Trees are very useful. That's a tree. There are a couple of things that trees are not allowed to have. Trees are not allowed to have things like that. That would be, they're not allowed to converge, right? If you imagine these as arrows, another thing that a tree is not allowed to have is an arrow back up. That would be a cycle. Trees are not allowed to have cycles. Not allowed to have cycles. And basically, the rule with a tree is every node has at most one parent. And the only thing that doesn't have a parent is the root node. And that's how you define a tree. By the way, what do you call a collection of trees in computer science? You call it a forest. That is a true fact. A disjoint collection of trees is called a forest. So what do you call disjoint tree compression in Java? This is like the worst joke ever, but I'm going to tell it anyway. What do you call disjoint forest compression in Java? Espresso. Anyway, did everybody get that done? Yes.
Small question. In the interfaces, it says that the public is redundant, putting in the public, because it works without it and stuff like that. And if you scroll over it, it says redundant.
Yes.
So it just wouldn't need that, but would you want us to put that in if it says public on there? Like for an assignment?
For an assignment, if it says it's redundant, then you don't need it. There you go. Sure. So,
You won't lose marks if you have it in there.
you won't lose marks unless it doesn't compile. The way that you lose marks is it doesn't compile, it doesn't do what it's supposed to do, or you've documented it poorly, or you have messed up your UML diagram. That is how you lose marks. On an assignment, anyway. So yeah, I mean that makes sense, right? How can you have a private abstract class. The whole point of the abstract class is you're passing the definition down to the next layer for it to be overridden. If it's private, there's no point, right? Private, it hates it. It's like, you're stupid. Private methods in interfaces should have a what? Okay, so you can do that, but you just gotta give up. Turn. What? Interesting. Okay. The treatment of interfaces in this course is introductory. They go a lot deeper than we've been able to cover, shall we say. This makes sense though, right? Like, you can't override a private method, right? Private methods are not exposed to the subclass, to the child class, so you can't override them. The whole point of these is that you're overriding them, so it doesn't make sense to have them private. Make sense? Java does make sense. It does make sense. You just have to reason everything out from first principles, because it's Java. Okay. Any questions? Any further questions? Okay. All right. So I'd like to jump ahead a little bit in the notes, because like coming up in the material that we may not have time for, there's a good example of like why even interfaces, like what is even an interface for? Why are we torturing ourselves with these? I'd like to show you that because it might help motivate this. Typically you're supposed to do the motivation before you do the lesson, but you know. Teaching methodology is for wimps. It's for wimps who don't know the material. So why aren't you using one then? Wah.
The array list API.
Yes, exactly. So, array lists. Array lists. So, I did my thing about arrays versus lists, right?
Yes.
Good. So, you may be saying to yourself, how could it possibly be that we have array lists, because arrays and lists are two different things, right? What gives? So, check out this UML diagram, which represents stuff that is in the actual Java, like, this is real Java code in Java itself, right? So, array lists, right, are arrays which implement the list interface. Where's my sword? Where did I put it? There it is. So, we have array lists. Array lists implement this abstract class, abstract list. I couldn't tell you the purpose of it because it's blank on this diagram. It probably has a lot of stuff in it. Abstract list implements interface list. Interface list requires everything that implements it to have add, clear, contains, get, index of, is empty, last index of, remove, size. Typical list functions, right? Not typical array functions. As we discussed previously, something like remove element at index I is actually fairly expensive on an array. because you have to shift everything in the array down into that slot, right? So worst case scenario, the runtime of that is proportional to the length of the array, because you have to move every single item over by one, right? So that being said, arrays are very fast for lookup, and most of what you're going to be doing is lookup most of the time. So Java provides the array list. They are arrays in the back end, but they provide the interface of a list. So it is an array. It is implemented in memory as an array. It's packaged with all of the list methods, no matter how expensive they are, right? So, remove gives you an array-based implementation of remove inside of the array list class. Linked list and list are the same thing, basically. The link in a linked list is the pointer to the next node, right? Linked lists implement the same interface. So, because array lists and linked lists both implement the same interface, they have the same set of methods available, right? You can still remove on a linked list the same way that you can on an array list. It hides the implementation detail. It hides what sort of memory transactions are going on. It allows us to program with those details abstracted away. We don't have to know how the array implements it. We don't have to know how the linked list implements it. All we have to know is that we have the ability to remove something from both of them, right? And that's what interfaces are used for in Java's implementation of itself. Does that make sense? By the way, there are two types of languages. Languages which implement their own system of compilation and execution, and languages that do not. Java implements itself. Java runs on Java. Does Python run on Python? It does not. No, Python does not run on Python. Python runs on C. Python is written in C. So, does that make sense? Like that's the idea, right? Any questions? Did I give you a formal treatment of this thing? Would you like that? I think we have enough time. We have 10 minutes. We can do a slightly formal treatment of that thing. So that should be thought of as a type variable, right? The term for it, are they in, is it in here? I forget. Oh, come on. What's it called? Generic! It's called a generic. So, so let's say, just for the sake of interest, right? You see subtype polymorphism, and you're like, that's not enough polymorphism for me, right? You're like, I want even more. I want to be able to declare a variable of literally any class. Literally any class. If you sneak one of these in, right? Basically you're saying this class now takes another type as a parameter. You can now use T as a stand-in for a past class anywhere inside the code. So for example, public T something. No compiler error, at least at this level. Now that you've done that, you have to go to, like, everywhere you've used Goblin, right? Goblin now requires that you pass it something, and you pass it a type. Type argument cannot be a primitive. Okay, integer then. Good grief. It's not too much, like, it's not too much extra weight, because honestly, after you've declared it, how many times do you use the type, right? But now, the class integer is being passed into the Goblin class, and this guy here is now of type integer in that instance, right? Oh, that's a syntax error. Okay. So for example, if I say g dot something is equal to 5, right? S out g dot something. There we go, because it's public. Five, but if I change this to string, you can see I now have a type error. Incompatible types, int cannot be converted to java.language.string. You would have to do like some kind of quick and nasty type conversion on it, like this. Oh, that is the poor man's string conversion right there. So, so that's what generics are and do. You can see how that might be useful within the context of something like array list, right? Because, you know, what's one thing that we have to know in order to declare an array?
Type of it.
The type of the array. Arrays happen to be monotyped, right? So if we declare an array list, this begs the question, an array list of what? Right? In order to declare the array that underlies the array list class interface for the list, you need to know what the type of the array is. So,
Base class.
exactly. This type parameter, this generic, allows us to say, I want an array list of anything, actually. I want an array list of goblins. Array list of goblin. Gobbles equals new array list of type goblin. And that is true and valid, right? So you don't often run across generics. Like they're not, you have to know how to use them a lot more than how to define them. Like a lot of the stuff that you would need a generic for, you'll probably find something in Java already that does that, right? But for example, if you were defining like, oh, I don't know, let me think for just a moment, maybe later on in a particular program you're taking, you're going to have to take data structures and algorithms, and maybe that course is going to be taught in Java. And maybe you'll have to define nodes for a tree in Java. And maybe a generic is exactly what you use to make that an array, a tree containing only integers to a tree containing anything. Right? So that's what generics are for. They're very useful when you're doing like abstract data structures-y type stuff, But for your kind of day-to-day programming, and particularly the stuff that you're doing in this class, like you won't really have to use them or need them. But hopefully you remember these last 10 minutes of class when you arrive at data structures and algorithms, and perhaps you'll think of me fondly because I told you how to do it and before you needed to know how to do it, which is always better than knowing after you need to know how to do it. So, any questions? Well, in that case, I guess I don't really have anything more to say today. Thank you very much for your time and attention today, folks. Next week, we will be covering exceptions and mouse events. It's a bit of a lighter topic. I could literally give you everything you need to know about exceptions in the 2 minutes remaining in class. You want me to do that? Okay. So, first thing about exceptions, when an exception is thrown, you catch it with a try catch. Alright? If you have some code that might fail, a good example of this is like the scanner, like in.next int, right? If you don't actually give it an int, that causes an exception. To catch the exception, you put it in try, catch, you put some gobbledygook in there. If an exception happens while this code is executing, it stops executing that and executes this. S out. Whoops! There you go. And also, you can raise your own custom exceptions by using throw new, whatever the exception type is, exception. Give it a message. And that's how you can create your own custom exceptions inside of classes. A common use case that we use this for in this class is, oh, you called this method with an integer that was out of range, right? Rather than doing something nice like asking them to repeat it, you just cause an exception, which, if unhandled, will crash the whole program. So yeah, that's exceptions. That's what we're going to be doing next week. You now know pretty much everything you need to know from a conceptual standpoint. We just have to do a couple of implementations of it. And look, I did get that done in 2 minutes. Ha! There you go. All right, get out of here. Go. Go have fun. And mouse events are not substantially different from what you've been doing in JavaScript.
Okay, so then we will have time to cover array lists.
But we kind of already have.
Oh, I see what you did there.